Hello all, welcome back to Quest 0. We'll look into the next problem on projection of lines today. It is a little different than what we have studied or solved till now. The question states as the top view of a 75 mm long line named as AB measures 65 mm while the front view is 50 mm. Its one end A is in HP and 12 mm in front of VP. Draw the projections of AB and determine its inclination with VP and HP. So this numerical compared to the previous solved problems, we don't have the angle at which the line is making inclination to HP and VP. But instead of that, we do have the projected lengths in top view and front view given directly. And also, we have the true length given, which is 75 mm. And one of the points, unlike in the previous problems, instead of being above HP and in front of VP, this point lies on HP and it is in front of VP. So the very first thing that we'll do is we'll draw the XY line. Using your HP pencil, applying a normal pressure. I'd prefer to draw it for the entire length of the sheet. Name it. So this is X, Y, VP and HP. Now, the next thing that I need to do is I need to mark the location of the end A. So, the end A, he says, it is in HP. So, when he says it's in HP, in the front view, the point is visible on the XY line itself. So, this point is A dash. That is in the front view. When it is lying on HP, it gets projected on the intersection of your vertical plane and horizontal plane, which is nothing but your XY line. And it says it is 12 millimeters in front of VP. So I'll mark at 12 millimeter. I'll mark the projection of the same point. It is 1.2 centimeters. This point is A. Connect A and A dash with a projection line of with your 2H pencil or your HP pencil very lightly. So this is A and A dash. How do we proceed from here? We know the true length, which is 75 mm, but at what angle should I be writing the true length? That is unknown. But we do have the projections or projected length. So before I do it, I'll draw the locus for A dash locus I need not have to draw since it is lying on the XY line. But for A, I need to draw the locus. I'll use a 2H pencil. A line which is parallel to XY line. Need to draw it. Next, using your compass, what is the projected length in the front view? Projected length in the front view is 50 mm. Use your compass, measure 50 mm. And on or from A dash on xy line, cut an arc. This point where you cut the arc is your point B2 dash. So what we are doing is we are reconstructing it the other way around. Initially, in the previous problems, if you had observed, we would draw an arc from A starting from the locus or from A dash. On the locus, we'll draw an arc, and wherever it intersects with the end point of the true length, there we were getting the projected line. Now, since this length of the arc, it is equivalent to the projected length, therefore, we are first trying to point out B2 dash and B1, and then we'll proceed to obtain the end result. So, in the top view, it measures 65. So, measure 65. Mark it on. The top view gets projected on HP. So, on HP, we have A. So, on the locus of A, cut an arc. So, this is 65. You can name it if you want to. So, this is 50. Use a 2H pencil. So, this is 50. I'll draw the arrow mark, or I'll name it later. This is 65. I'll try to keep it parallel to the line. So, this is 65. 50. This is 65. This point is B1. Okay. Now, what we are going to do is draw a vertical line starting from B1 to B1 dash. We don't know where B1 dash lies, but we'll draw a vertical line. Similarly, from B2 to obtain B2 dash, from B2 dash to obtain B2, we'll draw one more vertical line in the horizontal plane. Okay. Now, using your compass, measure the 75 mm true length. Measuring the 75 mm true length. The true length, again, it starts from A and A dash. From A dash, cut an arc which intersects your projection line from B1, and similarly from A, cut an arc until it intersects the projection line from A. This point is B1 dash, and this is B2. Now, I need to draw the locus on these lines. Now, I have B1 dash obtained. I'll draw the locus at B1 dash. using a 2H pencil. Similarly, a locus at B2. Once these loci has been drawn, the next thing is to rotate your initial length measurements that you have taken. So from B1, draw an arc until it intersects the locus. Similarly, from A and B2 dash, draw an arc intersecting the locus at B1 dash. Now the intersection in the top view is B and the intersection in the front view is B dash. Join them with a 2B pencil since it is the projected lines. A dash, B dash, this is AB. So AB is 65 mm, A dash, B dash is 50 mm as it was asked. Now using your 2H pencil, connect A dash, B1 dash, that is your true length 75 mm. Similarly connect A and B2, which is again 75 mm. Now the question says determine the inclination with HP and VP. So the true length inclinations with HP and VP is, if I measure the inclination of A dash, B1 dash, it is 30 degrees. Okay. Let's say this is 30, which is nothing but theta, and the inclination of true length with respect to VP is 48 degrees. This angle (48 degrees), which is equals to 5. Next, inclination of the projected length A dash B dash, which is alpha, is 50 degrees. Okay, no. Okay. It is 49 degrees. This angle, which is alpha, is 49 degrees, and beta is 58 degrees. 59 degrees. Yeah. Beta is 59. This is 59 degrees, which is beta. So this completes the required measurements for the given problem. So we'll write it separately on this end. So theta is equal to 30 degrees, alpha is equals to 49 degrees, 5 is equal to 48 degrees, beta is equals to 59 degrees. The solution can be a little different, as I told you, since we are using only a scale to maintain the parallelity and perpendicularity of the lines. We may be deviating a little from the exact solution. So plus or minus 2 of the obtained measurement will be the actual measurement of the angle. So thank you. Please do like, share with your friends, and also subscribe if you have not subscribed. We will continue with the last problem in projection of lines in the next session. Thank you.